calculating change in enthalpy, what you simply do is you subtract the heat content of the product from the heat content of the reactant. Whether 1, 2, or a million, we don't really care. We're having our change in H enthalpy to be equal to H product minus H reactant. Of course, alright, good day everyone. It's good to see you guys on this channel. My name is Dr. Victor, and I'll be your tutor on chemistry today. Today we shall be looking at chemical energetics. I know chemistry is very related to any of you anymore, for those who have been used to chemistry. But you can't talk about chemical reactions without talking about how these reactions occur, because there is no reaction without energy transformations. And this is the reason why we are doing chemical energetics. So what is chemical energetics? Just by way of introduction, I'll just tell you that chemical energetics has to do with the various transformation in terms of energy that occur during chemical processes. And this could either be in form of enthalpy, entropy, or gives free energy. And when it comes to the first, which I want to talk about today, it will be enthalpy. What is enthalpy? Enthalpy is simply defined as a chemical energy that we have in any given chemical substance. For instance, every substance you know on earth has its particular amount of energy that it contains in itself. So your energy content is called enthalpy when it comes to a chemical substance. Now, that being said, we can't calculate enthalpy directly. For that reason, we have to depend on another medium, which is trying to get the change that occurs when chemical transformation occurs. This implies that what we can calculate is change in enthalpy. And for this reason, I will take us through two kinds of change. It could be negative or positive. Every time a chemical reaction occurs and we have energy being released, such chemical reaction is called an exothermic reaction, and therefore in that case we have a negative enthalpy for that reaction. And when energy is absorbed in the chemical reaction, we have a positive enthalpy for such chemical reaction. We say that chemical reaction is simply an endothermic reaction. Just to make things more realistic, just telling you that we have negative or positive enthalpy change will not really drive the point. In chemical reactions, we have various kinds of chemical reactions. We have the neutralization reaction, we have the solution, we have name them as much as you can remember in your mind. And I'm saying when we talk about neutralization reaction, you realize that every time we carry out a neutralization reaction, we have energy being released, and such a reaction is called an exothermic reaction. When we dissolve, say, sodium hydroxide in water, we have the container becoming very hot, and that means that energy was released. And that's what an example of exothermic reaction. And in that case, the change in enthalpy is simply what? Negative. Because what does that mean? It means that usually during the chemical reaction we have that, let me use this for instance, A plus B equals C. Each of these guys you see here have their own enthalpy, that means they have their own heat content. Now the heat content of A will simply be as, just permit me to just drag an arrow right here so you can see what I'm trying to say. We have H of E, we have H of B, then we have what? H of C. Now this is interesting. The only way this can only be positive is we call these guys reactants, as we all know, and we call this guy our product. And when it comes to calculating change in enthalpy, what we simply do is you subtract the heat content of the product from the heat content of the reactant. Whether 1, 2, or a million, we don't really care. We're having our change in H enthalpy to be equal to H product minus H reactant. Of course, our reactants here are A and B. Our product here are what? Our product here is just only what? C. If you put everything together, if this reactant happens to have higher value in joules compared to our product, we are going to be having a negative value for this, and that's what exo. If this is I'm correct, then if this is higher than this, you're going to have a positive value, which in turn is what an endothermic reaction. What does that really mean? It means your product have higher heat content than your reactant, thereby giving you what? An endothermic reaction, meaning that your reactant absorbed heat before the product was formed, and vice versa. Having understood this, I would like us to think through elements and see other examples by which this can be well understood. And with this in mind already, there are questions you can really answer when it comes to enthalpy. But before we go into those questions you want to really answer, I want us to see this part, which is what are the terms you need to understand when you are dealing with chemical elements. When you are trying to carry out calculation of these changes, you have to understand that in every chemical reaction we have what we call system and we have what we call surrounding. Now, what is a system? A system is literally talking about every single should I say, okay, apparatus involved as well as reactant involved in carrying out a chemical reaction. So that means the space within a container where we carry out a chemical reaction alongside all of the reactants we use forms our system. And everything outside that space is called our surrounding. Now it means that our system has a link with our environment, just like the way I am standing right here. I have air all around me, the air facing my surrounding, and my content as human being is my own system. So I could either have an interaction with the environment or not, or you can also call this surrounding environment. Now, when we have types of systems, we have the closed system, we have the open system, we have the isolated system. What's a closed system? A closed system is that system that has only a little bit of interaction between with the environment, in saying that all you can actually take from the environment is energy exchange, not matter. An open system can take both, I think I'll have to write this one, we have matter and energy. These are the things you can actually exchange. So in your closed system, let me take together, in your closed system, both this alone or other, only energy can be exchanged with the surrounding, not matter. In your open system, both matter and energy can be exchanged with the surrounding. That means the surrounding can supply matter and energy to the system, and system also take back matter and energy to the surrounding. But when it comes to isolated system, nothing can be exchanged.